Going to kind of get ahead of ourselves just a little bit. We're going to look at something called the molar mass, which we're going to learn how to calculate it in this unit. And the next unit, when we get back in January, we're actually going to learn where we use the molar mass as a conversion factor, because it's going to be part of our stoichiometry problems. So the molar mass is the mass of 1 mole, which you don't know what a mole is, but a mole is a way of counting out particles in a sample of something. So with your molar mass, it is the mass of 1 mole. Again, we're a little ahead of ourselves there, but you just need to know it's the mass of 1 mole because it's part of the conversion factor. So when we're looking at the mass of a sample of atoms, molecules, formula units, remember a molecule is something that is covalent, a formula unit is something that is ionic, and then an atom is a single element from the periodic table. They all mean the same thing. Like if you have water molecules, H2O, that is a molecule because it's covalent, but you have 1 mole of that sample, it's kind of like saying a dozen. What we're going to do is we're just going to use the periodic table to find what is called the molar mass in this unit, and then like I said, in January we're going to use it. When you find the molar mass, you always have 2 decimal places. Not more, not less. You always have 2 decimal places. And all we're going to do is use the chemical formula, and we're going to add up how many of each of the different elements we have, and use the mass that is given on the periodic table. So the big thing here is it has 2 decimal places, and with those 2 decimal places, the unit that we're going to use is in grams. Now before in the unit, earlier in the year, we used AMU, atomic mass unit, and when we were taking your protons plus your neutrons to get the atom's mass. Now we're talking about a sample of that element, or the molecules or the formula units or whatever it is. So we're going to measure it out in grams because we can go to the lab, and when we go to the lab we can measure out how many grams we have on a balance. So with your molar mass, you're always going to write it out like a conversion factor, where you'll have 1 mole is equal to however many grams from the periodic table with 2 decimal places. So your answer is always going to be written like this. You always have 1 mole is equal to whatever number you calculate in grams, or you can flip that if you want, that you have your number of grams is equal to 1 mole. I don't care which way you do it, but you have to write it in that way because it is a conversion factor. We're going to drop that into math problems. So when you find your molar mass, you're going to find the mass in grams, and it is the mass in grams in 1 mole of whatever we're dealing with. So these examples that I have here, I have a periodic table. It's the same periodic table that you have in your in your file folder, or that I gave you, already printed and everything. But we have the names. We're going to have to write out the formulas. So I'm going to go ahead and do that first. I'm going to switch over to my document camera here, and we have to write out the correct formula because I need to know how many zincs and how many chlorines are in this formula, how many bromines or how many diphosphorus pentoxides, how many phosphorus and how many oxygen. So I'm going to go through all of these and I'm going to write out the formulas first just so we have them handy so it goes quicker in a few minutes. So zinc 2 chloride, zinc has a +2 charge, chlorine is -1. So ZnCl2 is my formula there. Bromine is in Brinkelhoff. With bromine being in Brinkelhoff, that means that it automatically gets a 2 when it's a single element. So it's Br2. Aluminum, a single element again, is not in Brinkelhoff, so that one's just Al. Diphosphorus, di means 2. Pentoxide, pent is 5. So I have 2 phosphorus, 5 oxygen. Gallium acetate, gallium has a +3 charge. Acetate, ATE, means it's a polyatomic ion. That one has a -1 charge. So we have Ga, and then C2H3O2 with a 3 after it. Now that we have the correct formulas written, now we're going to have to find the molar masses. So when we go to find the molar masses here, I'm going to use my periodic table, and I'm going to look up the mass When I look up the mass on the periodic table, I'm going to add it together using my calculator, and then I'm going to round the answer to 2 decimal places. So you can either pull the numbers off of the periodic table using 2 decimal places, like carbon 12.01, you can do that. Or you can put in all of those numbers and then round it. You're going to get the same answer either way. It doesn't matter. I round it just to 2 decimal places when I pull it off the periodic table, so I'm not putting as many numbers into my calculator. So with this one, I have my zinc right here. I have 1 of them. So I'm going to take my 65.39 plus I have 2 chlorine. So I need to take chlorine's mass twice. So when I find chlorine on my periodic table, it's 35.45. So 35.45 plus 35.45. So you can do it like that, where you're putting in each number like zinc, chlorine, and chlorine. Or you can use parentheses, which I'll show you in another one down the road. But you just hit enter. We need 2 decimal places for our answer, which I already have. So 1 mole of zinc 2 chloride has a mass of 136.29 grams. So that's how I write my answer for that one. Bromine is Br2. That means that I have 2 bromines there. So I'm going to take 79.90 and I add that 2 times. So I'm going to put times 2. Save a little bit of work. So when I go to write my answer here, 1 mole of bromine has a mass of 159.80 grams. Aluminum is just aluminum from the periodic table. There's no numbers there, so there's only 1 of them. So with my aluminum here, 1 mole of it has a mass of 26.98 grams. Now my diphosphorus pentoxide, you have 2 phosphorus, 5 oxygen. This is where parentheses come in really handy with this one. It makes your life a little bit easier. So what I do is I open parentheses. Let me move this over just a little bit, sorry. 2 times oxygen, because it's diphosphorus, 2 phosphorus. So 2 times 30.97, close my parentheses. Then I'm going to hit plus, because I have to add them together, my 5 oxygen. So 5 times this 15.9994, that's going to round to 16. So that means that my diphosphorus pentoxide, 1 mole of it, has a mass of 141.94 grams. So it looks like that. Sorry. Now gallium acetate, this is another one where you're going to want to use your parentheses. You could have taken phosphorus 30.97 plus 30.97 plus 16 plus 16 plus 16 plus, that's just a lot of work. You can do this either way, I don't really care. But gallium, there's only 1 of them. So you're going to take 69.72 plus, open parentheses, it's C2H3O2, but there's 3 of them. So I have 6 carbon. So 6 times carbon's mass is 12.01, close parentheses, plus I have 9 hydrogen here. For my 9 hydrogen, I'm going to open up parentheses again and put 9 times 1.01, close up my parentheses, plus I have 6 oxygen, so 6 times 16, close parentheses. And that is my molar mass when I get an answer, which is 246.87. So 1 mole of my gallium acetate has a mass of 246.87 grams. So when you're finding your molar masses, you're just writing the formula if you don't have that already. Once you write your formula, you're just going to add up however many of each element are there, and you multiply it out. You'll never see numbers out front here for your molar mass because it's always the mass of 1 mole. So with your molar mass, it's just 1 mole is equal to, and whatever number it is. It's always 1 mole over here, and then the molar mass comes from the periodic table. So you do have some practice with these. If you guys run into any questions or issues, make sure that you go ahead and ask. Have a good day.